Welcome to Open Source Spotlight. We invite open source authors and ask them to show the tools they're working on. Today we have Andrey. Hi, Andrey. Tell us a few words about yourself and about the tool you want to show us.
Hi, Alexey. Thanks for having me today. Super excited to tell you about our new feature at dstack. I know we showcased dstack before, and today I'm going to show a very new feature called Fleets for working with on-prem servers. And without further ado, let me share the screen and get to the hands-on demo.
Yeah, I want to see that.
Awesome. So here we go. dstack is an open source tool, which you can learn more about if you haven't heard of it. Basically, it lets you run containers for AI workloads on both cloud and on-prem. And today we're going to focus on on-prem. In order to work with dstack, we have to start dstack server first. We can configure it with access to any cloud providers, with access to Kubernetes if we want. But today we are going to, again, focus on on-prem. So I have the server up and running. Here I have this URL in the output, which I can click at any time. And as you see, it opens the control plane. Control plane shows like what is running, like my fleets, my runs, and we'll get to it later if as soon as we run something. Imagine a situation when you don't want to use cloud for running AI workloads. Instead, you want to run those workloads on your bare metal or on some server that you have access to. Also, it can be a server in a data center. And all you need to access it through dstack is SSH access. Imagine that you have a couple of servers that are connected into a cluster that you have SSH access to. If you want to access it through dstack, we have to define a fleet. So let's see how this works. I create a YAML configuration file called SSH Fleet dstack.yaml. And in that file, I say, the type is fleet. I give it a name, and I can choose any. Then I can say the placement for this cluster for this fleet is a cluster, means that any hosts are interconnected. And then I'm basically providing their SSH creds to access those servers. I specify the user which I want to use. I specify their private SSH key, which I would use to access this server, and then the host. So for example, this is the host which I have access to, and I can even check that I have this SSH access. Same with their second host. We just check that we have access to it. And that's all.
What if, I'm just curious,
Sure.
what if I have two machines, but I need to use different user and different identity file for these hosts? Will I still be able to do this? Okay.
Yes, this works as well. Instead of giving a host name, you would specify their the username and identity separately, just for every node here. There's let me switch to dstack docs. We can find the reference also here for the fleet with multiple examples. Let me see, SSH config, n host. All right, should be somewhere here.
Yeah, I think it's the next one. That
host. Yeah, let me find it.
Yeah, if you scroll down, it says SSH config hosts, and then it's there.
All right. Yes. So basically, instead of just the IP address or host name, we can specify an object, and we can even override the port and user and private key as well. Right. So now get back. So imagine we've specified those hosts properly. So now we quit, and now we use the command dstack apply, which is a universal command whenever you want to apply something like create provision something with dstack, you always use this command dstack apply. And now we pointed to this fleet configuration. And it will check whether the fleet exists or not, whether we have to update it in place, or whether we want to create it. So now let's confirm that we want to create it. Now we have this fleet command that shows us the state of the fleets. If we add -w, then we would watch it in progress, and it takes a bit of time to download everything that dstack needs, detect the accelerator that is there, and now we can see that dstack detected properly their accelerator. We see that we have this amount of like disk space. We have NVIDIA L4 as an accelerator there, and it shows how much VRAM we have there. So now fleets shown as idle. Great thing is dstack is price aware, but in case of the bare metal, it shows that it's basically 0. In case we want to, for example, use cloud fleets and bare metal fleets side by side, dstack would always prioritize those that have less price. Right, so now let's see what we can do. With dstack, we have 3 basic scenarios: dev environments, tasks, and services. And let's start with the dev environment first. Imagine that we want to work with a remote instance through our IDE for interactive development. For that, we defined a dev environment configuration, which I'll show in a minute, but also pay attention to that. No, we're not using any commands here. Let's first look at the configuration. We define the type of the configuration to be dev environment. We can specify the version of Python or a Docker image. We can specify dev environments if you want. And then, of course, the most important is resources. And for example, let's say for my work, I need 24 gigabytes VRAM. Coincidentally, it matches exactly what we have in our fleet. And we can also specify the disk space which we need. That's all here. So now let me run dstack apply command. Now, instead of the fleet configuration, I pass the dev environment configuration file here. And this is what I wanted to say, that we use this reuse option, which tells that do not provision any new fleets. Ensure that we are reusing the idle fleets from the pool. Here we go. Confirm, we already ran it before, so it like exists. We're going to override the previous configuration one, and it shows here that, yeah, most likely we're going to use our fleets which are in the idle state that match their requirements. And now dstack, because those bare metal machines are connected to dstack as a fleet, dstack connects there, ensures that, well, Docker image is pulled, all the dependencies are pulled, and then dstack coordinates that execution of the dev environments there. And here we go. The status is running. Now it takes a couple of seconds to start the dev environment itself. By the way, if you have and in order to use dev environments, you would probably need a desktop VS Code, which we have here. Dstack automatically detects its version and ensures that the correct version is installed there. And it also installs there, well, any extensions which you would need. We specify the Python, so it installs Python. All right. And now it has configured the remote host with the name VS Code VLLM. This is their name, which we've given to the dev environment. So now we simply have to open that URL, which will automatically open the desktop IDE and prompt us to connect to that environment. So we see that it's VS Code VLLM. It has the code that we had in our local folder here synced up. We don't need to do anything else just to get started. And if we run this NVIDIA SMI, we're going to see that, yeah, we have NVIDIA L4. So, and dev environments basically is how you interactively work with your code, use your IDE. But there's just one use case.
And I am not connected to machine itself, but rather to a Docker container on the node, right?
Exactly. This is a great part, because typically when you work with bare metals, you either have to use Docker yourself, which really sucks, especially for AI teams, or you basically have to ignore Docker and then you basically just have to run the commands on bare metal, which is bad because then you can, well, it depends on the state of the machine, and the commands not independent means that you can easily break up things, and then especially if the host is used by multiple team members, then you could go into trouble.
Mm-hmm. So here, the way I see it, the way I understand it is when we finish our session, the Docker container, the images, the containers are gone from the host, from the node, right? And then it's like back to the clean state.
Exactly.
And then everyone else can just continue with their own dev environments and they don't interfere with each other, right?
Yeah, yeah. And teamwork is a very important use case for dstack. It's not only a fresh state. Every time you run something, dstack also takes care of scheduling things. For example, if we have a team that runs concurrently multiple things, dstack takes care that all of those workloads are queued. Right, so now let's look at something else. Imagine you want to run a batch job. It could be a training or fine-tuning. And then we also now going to look not at a very simple one, but let's look at a complex workload. Imagine that we want to use the entire cluster for training. And we are going to define a task configuration. We say type is task, and then we say we need two nodes here. Now, in the commands, we can run any arbitrary commands we want, but here we can use system environment variables, which dstack propagates to their configuration. Dstack GPUs per node, dstack node rank, master node, etc. And this is very important because then you can use any distributed framework you want to use. In this particular case, we are using Torchrun, but you can use any other. You can use Spark or Ray or whatever. And with those environment variables, dstack lets you know which node that is. And then when you run this, dstack takes care of first scheduling the master node and then the other nodes. What we do here is running a very simple distributed workload. We just like check out the PyTorch ResNet distributed example, and then run the training. So let's now give it a try. Apply, fine-tuning, and we again specify this reuse option to ensure that dstack doesn't provision new fleets. Now you see that instead of running one job only, it runs two jobs. The run name itself, we haven't assigned any run name, so it's rare chicken name. It's rare chicken one. And then we have two more numbers. Second number is a replica number. This is typically used for deploying services. In our case, I'm sorry, the last one is a replica, and the second one is a job number. Because we have two nodes, we have two numbers here. So now we see that dstack successfully provisioned both workloads, and it runs this script on both nodes. but important, it propagates those environment variables. And that's how Torch Run or any other distributed framework knows how to basically coordinate the distributed workload. And what is great is that dstack doesn't have to think of it. It's all delegated to the framework itself, and the user can decide which framework to use. For example, if you are training or fine-tuning LLM, you could use Hugging Face Accelerate framework, which is a wrapper around PyTorch DDP, and well, it's not just DDP, but a few others. But basically, it works same way. As a user of dstack, you don't have to go there. You just pass this accelerate command, and dstack pass it to those environment variables, right? Just waiting now for pip install. And as soon as it's in, yeah.
While we're waiting, maybe I can ask you something. So I'm wondering, what do I need to have on the nodes in order for dstack to actually pick them up and add to Fleet?
Good question. If we go to the dstack documentation, we'll see that in order to let you use SSH Fleets, you would have you would need Docker on each host, and if you plan to use GPU, you would also need to ensure that drivers are installed there, and that's all you need. So now we see that
I noticed that you used images from AWS, right? So it was Ubuntu images from AWS. So what you did is you got a fresh instance with a GPU, and then you installed Docker there, you installed the drivers, and then you installed Docker GPU, right?
You are talking about the way we provision cloud.
No, I mean before we could do what you did today, what you showed us. So you did some preparation work, and I was wondering what this work was.
Yeah.
What exactly you installed there?
For this particular demo, I created two machines in AWS because I don't have bare metals myself, and I installed Docker and NVIDIA drivers. There are multiple community images in each cloud, and dstack also provides their own community images which you can use. But then it's entirely up to you how to do it. You just need Ubuntu, and you need Docker and NVIDIA drivers.
And Docker GPU, I guess, too?
True, that's what I mean with the, yeah. I skipped that part, but basically you need NVIDIA Docker, not just Docker, but NVIDIA.
Yeah. Okay. Yeah. So I interrupted you. It was already training, and you wanted to say something.
Yeah, it's training. So now we see that it successfully launched as a cluster workload. So now we can interrupt it. We don't have to wait until the training ends. That was just to show you how you can run any kind of tasks on your bare metals, let's say with dstack. And some may wonder, okay, so typically when it comes to on-prem, often people resort to using either Slurm or Kubernetes. And this is where dstack stands out, that first, you don't need Slurm or Kubernetes. And as you've seen, dstack makes it very simple to use any on-prem host. You only need to have SSH access. You don't need yourself to install anything. And second, dstack covers not only training, but it also covers two other use cases, which is dev environments and deployment. And now let's talk about deployment a bit. So imagine that we want to deploy a model or run a model. And again, when we say deployment, well, in 95% of the time, it's not production deployment, it's actually development deployment, because you're playing with an LLM, you want to run this LLM and you need infra for that. Especially if it's large one, you don't just run it on one machine. And then you probably would need to build some RAG on top. You would need to integrate it into the product before you even go to production. This is called the AI development stage. And let's see how this tech helps with that. Imagine we want to play with a model. Right. And here I have an example. Oh, not this one. Service. Here we go. Again, the type is service. I also assign name. I specify which Python version I need, some of the environment variables. And notice here, if I don't specify the value for any environment variables, it means that this tag expects it to be specified when you run dstack apply. And I'll show you where the value come from in this particular case, because it's very convenient. Then we use VLLM here, even though you can use any other framework for inference. We can specify the requirements. And then the last part, model. We say it's not just a service, it's actually a model. And then we say it's OpenAI compatible model. And we say that, yeah, chat model, that it's a chat model. And then we assign it a name. And we're going to see what happens next. Right. Now let's try to run that. VLLM service. Here we go.
When we use on-prem, we always need to do ---- reuse, right?
Not always. If we don't have any cloud, let's say backend configured, we don't care. This tag uses only their existing fleets. However, then also you can specify that reuse policy in the YAML file, for example, in the service.dstack.yaml. But because I don't have it specified there, I add it here, and it's just basically a habit now. When I want to ensure that it runs on a provision fleet, I use reuse.
Otherwise, it would attempt to get a new machine from AWS, right?
If it cannot find an existing idle fleet that matches the requirements, which in our case it would find it, but theoretically speaking, imagine that your fleet are busy doing something else and you still want to run it, and if you don't say reuse, it will provision, because the default creation policy is reuse or create, but you can change it to either create or to reuse. So by the way, while we're waiting for the service to start, in order to use services, you have to configure gateway. And now, actually, with dstack, we are working to make it optional. But right now, if you use dstack, you would have to configure a gateway. Gateway is something that handles the ingress for any service that you deploy. And with dstack, you have gateway.
And by ingress, you mean what exactly?
With ingress, I mean that it is possible to define how a public endpoint is created. And you can map it to, for example, a domain. And dstack ensures that a HTTPS certificate is provisioned for that endpoint. But that's only needed when
it's like a load balancer from AWS, right?
Yes. And then with the service, you can also specify the number of replicas, like a range of replicas, dstack auto scales them, and gateway serves as a load balancer here. But it's not only load balancing, it serves many purposes, like authentication, load balancing, ingress. Yep.
But I meant like in AWS, if you need all that, you just use Elastic Load Balancer or whatever, right?
Yes. And with dstack, because dstack is agnostic, to any cloud or on-prem, we have this thing called gateway. But we're actually working on making it optional, so you don't have to create a gateway. But for this particular demo, I've created a gateway with AWS. Even though the workload is running on bare metals, for the endpoint, for the public endpoint, which we wanna create, we are using AWS gateway. But as soon as we support the built-in gateway, which probably will get to the next major dstack update, you would not need to do that. Dstack server will serve as a gateway. So here we go. Let's see where we are. All right, we're almost there. We just have to wait because it's a cold start. We need to wait until the weights are downloaded.
And
once
you mean by cold start, you mean that next time we run, it will be faster?
Yes, this is possible. Dstack stores the cache on the host. And if it's a warm instance and the cache is there, it depends, of course, if you get to the same host.
Yeah.
If cache is there, then the start will be faster. And dstack also offers the concept called volume. It's not supported yet for SSH Fleets. Only can be used with cloud fleets, but eventually we'll support that on-prem as well, which allows you to mount network volumes. And then this cache can be stored there. And this is how you now avoid cold start in cloud when you run with dstack.
So you basically re-implement the whole Kubernetes, right?
Not all of it, but
so you
this
have
is
like nodes, volumes, ingress, what else? Like services.
True. Those things we replicate. However, we mostly focus on the AI workloads, where with Kubernetes you would need something on top. So now let's need to wait.
But it also works with Kubernetes, right? So if, let's say, I already have an on-prem cluster with Kubernetes, I can use dstack to
yes.
submit my jobs there. Okay.
Yeah, let me maybe even open that part of the documentation. Here we have a list of all the backends which are supported by dstack, and this includes the cloud providers. This includes this built-in SSH provider which we are using right now, and there is this Kubernetes backend, and you can use either self-managed Kubernetes or managed Kubernetes. If you want to just play with that, you can use Kind. You can just install Kind locally, create a Kind cluster, and then connect it to dstack. Even though we still recommend people, when they have this chance, to go with SSH because it's a lot simpler. You don't need to manage the Kubernetes cluster. But yeah, you're right.
I imagine if I have like a computer with a GPU just under my desk, I don't want to install Kubernetes there, but I also want to have a convenient interface to access it. Instead of just SSHing and letting the entire team to SSH to this machine, we want to have some order there.
Yeah, right? And this is what we want. If you have a choice, we want to let you not use Kubernetes. Loading, save tensors, checkpoint charts.
Yeah, it takes a while usually. But next time, I guess the only thing that will happen is loading the checkpoints.
Yes. Yeah, loading the checkpoint charts, yeah.
The rest, how does it actually work? Like, I know that when you do Docker build, it saves, it caches, and then you have an image. But if it's an already running container, or you actually do first Docker build and then run, how does it work?
To be entirely honest, cache thing is not public yet. Cache, but in the end, cache is when dstack runs any workload, it typically mounts it mounts volumes. And in the case of the cache, it simply mounts a local host folder. It means that whenever we run anything with dstack, mounts a cache folder.
No, that's smart.
Right, so we see that it's up and running. So now what we're going to do, we're going to go to the interface. Now, by the way, this is a good chance to look around. So here's my run, and I have logs here. I see the status. Here's I can see the fleet status, and it shows the fleet instances. And I see that one is idle, one is busy, or yeah, I can switch between active fleets and not active fleets. We have model here because we've mapped our service to a model name. So now dstack understand that this is a model. This is not just only a service. And dstack also offers this playground. I mean, it's not a big deal, but often when you experiment with models, you want to play around with this model. So now let's just check how this model works. If we switch back, we see that there are logs, access logs again seen. So now you see that the model responds, and this model is available on the gateway endpoint, which we've configured, and because it's OpenAI compatible endpoint. If we deploy multiple models, all of those models are going to be available there by name, just like with OpenAI. This deck automatically handles their authentication. Here you have users, and you can bring your team. Here, every team member has a token, and then all the models can be accessed only through the token. However, you don't always have to run models with this deck. A service in principle can be any web application. This deck handles auto-scaling and authentication, but in the end, you can run any Docker image and any program. So I guess that's mostly it. What I wanna show to you, and
That's
invite
amazing.
everyone
Yeah.
to play with that, and also ask questions in our Discord channel if they have them.
And I know I can see how to find your Discord channel if I already run this stack. There is this link to Discord in the bottom. But what if I don't run it yet and I want to join your community?
Absolutely. So the best way is to go to GitHub, find this tag there, and we have this Discord link here, or go to the website, and then we have this community button.
And then there is another button which is also quite important if somebody has not started this stack yet, that they should do it.
Exactly.
Hey, I know we are running out of time, but I still want to ask you a few questions. I'm wondering how many people are working on this stack.
So we are now 6 engineers in total. Most people work on the core part. I mean, I include myself as well, even though these days I spend a lot of time with documentation and examples as well, not spending so much time on the core development, but still doing reviews from time to time. One person is full-time now on examples. And if we go to examples, let's say you can find here how to use Axolotl for fine-tuning. And if you go there, there are multiple things. There's this alignment handbook if you want to use a Hugging Face tool for alignment of LLMs. Yeah, TRL is a very simple one, but it's a very powerful framework. Maybe mentioned here as like as a promotion, because this stack is not only NVIDIA, it also supports other accelerators. We have examples for AMD and TPU, and we actually now spend a lot of time to ensure that this stack runs smoothly with AMD and TPU. And if you wanna play with AMD, we invite you to check out the examples.
Okay, interesting. And what are your plans for the next quarter?
Oh, let me maybe mention one thing. If we go to GitHub repo of this deck, and I would love if people that watch this check the repo and give us a star if they haven't yet, but also look at their issues, and we have this roadmap pinned issue. This is for Q3, which is, well, we are kind of in the middle of it, and it actually ends pretty soon. But here we see what we are working on right now. And we see that a lot of stuff have been successfully accomplished, like in this quarter, but we still have a number of things here, like be it the improvement of the dstack apply. We have a lot of requests around the gateway. When I mentioned that we want to make gateway optional, because sometimes you don't really need a public endpoint. Let's say you would settle with an internal endpoint, but you still want to run models. You want to experiment with them. That's what we are working on. Then also add health check for the gateway. Right now, dstack doesn't check the health of the endpoint. It only checks the health of the container. Improve the support for clusters. For example, with TPU, we are working on supporting multi-host workloads as well, and many other things. So basically, invite everyone to check the roadmap. There is a long list of examples if you'd like to have to make it easier for people to get started, and then also like research topics, like such as like how to handle fault tolerant, how to bring fault tolerancy, how to track metrics and things like that.
Amazing. Well, thanks for an extensive demo and for sharing your roadmap. And also now, if somebody wants to contribute, they know how to do this. Do not forget to give dstack a star. And thanks, Andrey, again for doing the demo. I hope everyone enjoyed it.
Thank you, Alexei, and thanks everyone for watching it.